All right, problem number 5. So here I'm asking you to evaluate a decent number of different limits. 7. So let's go ahead and look at that. Part A is limit x goes to 5. I'll just write it. So evaluate these limits of x cubed plus 2x squared minus 5x squared plus 3. There's two squared terms here, which looks a little weird, but nothing crazy going on there. X goes to 5. X cubed minus 3x squared plus 3. Not bad. And the first thing you should always do when you're looking at a limit is plug in and see if it works. Because if you can just plug in and get a value, then you're done. So let's try that. 5 cubed minus 3 times 5 squared plus 3. So 5 cubed is 125. 3 times 25 is 75. So we're at 50 plus 3 equals 53. So we tried our first resort, which is plugging in, and that worked. So that's all we had to do. Limit as x goes to 3, 2x squared minus 5x plus 2 over 2x squared plus 7. So again, let's just try plugging in 3, see what happens. 2 times 3 squared minus 5 times 3 plus 2 divided by 2 times 3 squared plus 7. So let's work out the top and bottom. 3 squared is 9, times 2 is 18, minus 5 times 3 is 3, plus 2 is 5. So the numerator you get 5. On the bottom you get 25. So we get a final answer of 1/5, and plugging in just worked. Nothing too crazy happening there. So these problems are just to remind you, before you go to any annoying, hard to do stuff, trying to mess with limits, you might just try to plug it, or you should just try to plug in first, because it'll make a good number of problems easier or less annoying. Limit x goes to pi over 4 of, pi over 2 of sine x cosine x. Okay. So again, let's try plugging in, see what happens. Sine pi over 2, cosine pi over 2. And now let's see if we remember what these values are. So sine of pi over 2 is equal to 1. Cosine of pi over 2 is equal to 0. So that's our answer for part C. And I'm just going to have a little blue line separating some parts, so it's more obvious where each one starts. All right, so keep going. The limit as x goes to 4 from the plus of x minus 4 over x squared minus 16. So here we try to plug in again and see what happens. That'll be in purple. So I plug in 4 on the left, or on top, I get 0. I plug in 4 on bottom, I get 0. So if you remember from class, this is called indeterminate form, which just says somehow we need to do some fancy tricks to make the limit look different, to make this thing look different. So what's the trick that we do? This is limit x goes to 4 from the plus now of x minus 4, and we factor the bottom. So we have x minus 4 times x plus 4. For some reason I like to have parentheses on that before I cancel. I don't know why. Oops. Those cancel, and I get limit as x goes to 4 from the plus of 1 over x plus 4. And this is a limit that I can just plug in. So I get 1 over 8 as my final answer. I want to note something kind of intricate here. These limits are the same, this one here and this one here, but their functions aren't quite the same, because when I look at this function, the 1 over x plus 4, that function is defined except when x is equal to 4, because that was that removable discontinuity that I got rid of. But the reason that I can say the limits are the same is the fact that the limit doesn't care what happens at 4, just what happens when you're close. So I just want to point that out if you're curious. Okay. But that answers D. So part E, I'm asking you to find limit as x goes to 5 of square root x minus 1 minus 2 over x minus 5. All right. So when you see limit and you see a square root, you should immediately be interested in multiplying by the conjugate. First, I'm going to try plugging in. If I do that, I get 5 minus 1 is 4. Square root of 4 is 2 minus 2 is 0. 5 minus 5 is 0. So indeterminate form again. Nothing to be said. That gives us that we actually do need to do some work. And now I'm going to go ahead and multiply by the conjugate. So let's go ahead and do that. So times root x minus 1 plus 2 over root x minus 1 plus 2. And the whole reason we multiply by the conjugate is because you get the square root of the thing on the left. So I have x minus 1 minus the square of the thing on the right. So minus 4, all divided by x minus 5 times square root x minus 1 plus 2. And I can't forget my limit. The reason is the limit is just a number, but if I don't write the limit, then I'm saying a number is equal to a function, which really doesn't make sense. So we have, this is limit as x goes to 5 of x minus 5 over x minus 5 root x minus 1 plus 2 equals limit x goes to 5 1 over root x minus 1 plus 2. So not my most clean work there at the end, but that's what it is. So let me write this out more cleanly. 1 over root x minus 1 plus 2. And I'm just going to go ahead and get rid of this because it's unpleasant to look at. Sorry, I just kind of hit the mic there. Now can I plug this in? This is 1 over root 4 plus 2. I don't need the limit because I plugged in. Equals 1/4. So that's my final answer for E. Okay. 2 more limits to do. But that's the end. No, it's not. I just said 2 more to do. F. Limit x goes to 1 of 2x over x minus 1 squared. So let's try to plug in here, see what happens. So if I try to plug in, I get 2 times 1 is 2. 1 minus 1 squared is 0. So earlier we talked about indeterminate form. This is not indeterminate form because it's not 0 over 0. It's some number over 0. So whenever you have a number over 0, you're thinking infinite limits. So now your main goal is to see whether or not it's positive or negative. So let's look at both sides. Limit x goes to 1 from the minus. 2x over x minus 1 squared. Let me write it like this. So I'm going to get 2 on top times, and then I'm going to write a plus, because no matter what this number is, it's x minus 1 and then squared, so it's going to be positive. So this is equal to positive infinity then. Because I'm taking a number that's getting really close to 2, I'm dividing it by a really small positive number, and I'm getting infinity. But positive infinity because the sign is 1. From the plus, because this is squared, it's going to turn out to be the same thing. 2 over something positive, again, is plus infinity. So I get limit as x goes to 1 of 2x over x minus 1 squared is equal to infinity. Again, if the limit is infinite, I want you to say that it's infinite, not just that it doesn't exist, even though that's technically true. So just keep that in mind. Now we have one last limit to look at. G. Limit as x goes to 0 of, from the minus, of cotangent of x. So I'm taking a limit from the left of cotangent of x. Let's take a second to remember what cotangent is. That's cosine of x divided by sine of x. And now we see what happens. So I'm going to try to plug in. Cosine becomes 1, sine becomes 0. So now I just need to see if this is positive or negative. So let's see. So cosine x goes to 1. And as we're coming at sine x from the negatives, if you remember what sine looks like, or if you use the unit circle, that's going to say that we are a negative number. So that's what that minus is going to stand for right there. So we have 1 over some negative, and this is going to imply limit as x goes to 0 from the minus of cotangent of x is equal to minus infinity. So as an exercise for you guys, one thing you might try is you might try to see if what the limit is on the other side. Show yourselves that that limit is actually positive infinity. The limit as x goes to 0 from the plus of cotangent of x. Would be a great thing to prove to yourself. Okay, but that's it for all these limits. There was a little bit of everything in here. The only kind of example that I really missed, but you'll still see it in the derivatives, is one where you have a fraction and you have to get a common denominator. There's not an example of that on here, but everything else is pretty much covered. So that's number 5.